So yung problem natin today ay isang simply supported beam with the distributed loads and a concentrated moment. The problem statement asks for two questions, for two things. Number one, yung shear and bending moment diagram. And using that shear and bending moment diagram, makukuha natin yung sagot doon sa pangalawa, which is yung magnitude and location of the absolute maximum moment. So let's start with letter A. No? And to draw the shear and bending moment diagram, you need to start sa free body diagram para ma-solve mo yung support reactions. So ito lang, in-isolate ko lang yung beam with the loading. You can see here the dimensions. And we know that sa roller, meron kang isang reaction. Tatawagin ko yung A, tapos i-assume ko siyang pataas. Okay, so that's just an assumption na pataas siya. And yung sa C, that's a pin. So we know na meron siyang dalawa, no? And I'll call it C sub X and C sub Y, and I assume ko na both positive yung mga vectors natin. That's why you can see there you have to the right and upwards. And then next, you need to replace yung distributed loading by a single equivalent concentrated load. So that means meron ako dapat isang vector na nasa gitna ng distributed loading. Hence, may makikita ka ditong 3. Okay? So 6 divided by 2, that's just 3. Tapos yung magnitude ng equivalent loading na yan is simply 15 times 6. So the magnitude of the distributed loading times yung length ng span ng distributed loading. And that gives us 90. So we're saying that the effect of the 90 kilonewton concentrated loads statically is the same as that of the distributed loading, in magnitude at least. And then we used that equivalency to solve now for the reactions. So solve natin yan gamit ang summation of moments. Yung convention na ginagamit ko dito is counterclockwise positive, no? So starting with A, and just to give a short recap, no? So ito yung vector A. To take the moment of A about 0.6, about point C, you need the distance of the shortest distance of the of the line of action papunta doon sa point C. So that is, if I draw a line of action ng vector A, so that's a straight line, and punta ka sa point C, tapos yung shortest distance should be this one, yung perpendicular yan. Okay? And that's just 6 plus 1.5. That's by right-hand rule, you'll be able to get that the moment of A about C is negative. So all those are previous lessons, so I hope you're well-versed with getting moments, no, of forces, kasi kailangan siya sa pag-solve ng reactions. And then yung Cx and Cy, of course, wala tong moment about point C kasi nandun siya sa point C. So meron tayo ngayon is yung 90. O anong moment arm na 90? Madali lang. So yung line of action ni 90, ito yon. Tapos ano yung shortest distance from that line of action? Oops. From this line of action papunta sa point C, ito yun, no? That's 3 plus 1.5. Okay. So you can see there are 3 plus 1.5. And unlike vector 8, there should be a positive moment. Next, ano pa? So yun yung forces natin, no? So dapat equal to sa 0 as our moment. Summation of moments equation dictates. Pero, ayan, meron tayong common mistake dyan. Kasi kadalasan, nakakalimutan yung applied. So meron kang applied moment na 45 kilonewton meter na counterclockwise. So by convention, sa summation of moments, this should be positive 45. And yan ay yung complete na moment equation natin. You can see there that you have one equation, one unknown, masosolve mo na yung A using shift solve. Pwede na yan. Kasi sa perspective ko, hindi naman importante ipakita pa yung algebraic manipulation para ma-solve yung and isolate yung A on one side of the equation. Ang tinetest ng mga teachers dito ay yung pag-statics nyo. Ito, pag-setup ng equation. Kaya normally, okay na mag-shift solve sa part na to. And if you use shift solve, ang makukuha mo is 60 na positive. Ano ibig sabihin yan? Ibig sabihin, tama yung inassume nating direction ng vector A. So, pataas siya. Yan. Right? So, yun. So, para makuha naman yung Cx and Cy, pwede na tayo mag-summation of forces. So, unahin natin yung Cy, gagamit ako ng summation of forces about y, along y direction. And unahin ko yung A. So, and 90. So, negative kasi pababa. Dapat i-reflect ng free body diagram nyo yung equation niya. Plus Cy, and then this should be equal to 0. Okay? Then you can solve for Cy kasi you know A, nasolve na natin yun. Lagay mo lang dyan pabalik. And then you get Cy na 30 na positive 10 pataas. So we're left with Cx na lang. Pero sa mga beam problems kasi, normally, wala namang horizontal load. So kapag nag-sum ka ng forces along the horizontal, the only vector there is yung Cx. And yun, so that gives you Cx is equal to 0. So normally ganito siya sa beam analysis. Pero sa video natin, pinakita lang natin for completion purposes. Now, let's start with the drawing of the shear and bending moment diagram. No? So paano ba mag-drawing ng shear and bending moment diagram gamit yung loading? Unang-una, hindi mo dapat gamitin yung equivalent. Dapat doon ka sa original load. Okay, so next, ang mong gagawin is pag-identify ng pertinent points. So ano ba yung pertinent points? Yun yung mga important points doon sa diagram mo. So paano mo malalaman ano yung pertinent points? Iyon ay yung mga points of application ng applied forces and moments. Okay? Bakit? Kasi yung mga applied forces and moments, nagkakos siya ng mga sudden change doon sa diagram mo. So from there, bilugan na natin yung A. Okay? Identifying that this is a pertinent point. Nandiyan yung application ng 45 and 60. And of course, yung C din. And yung application ng 30. And start and ends ng distributed loading, those should be pertinent points. So we already identified that A is a pertinent point, so ibilog niya. And what's left is yung pagbilog ng B. So we identified 3 pertinent points. So from there, you can draw 3 vertical guidelines kasi you know na magkakaroon dyan ng mga changes in values no, ng shear and bending moment. So yeah, starting with the shear diagram, I always like to put blank beam. Tapos place ko yung V for shear and then yung unit ng shear diagram, which is kilonewton. Okay, now we start with the leftmost pertinent point, okay? A. Yeah. So at leftmost pertinent point, ang kailangan mo lang gawin is isum lahat ng concentrated loads. Since 60 lang naman yung concentrated load at point A, then we know that yung value ng shear at A is 60 positive. Bakit positive? Kasi pataas yung loading. Yun yung convention natin sa shear diagram. And yun, reaction lang yung meron. That's why meron ka dyan dapat na jump. Okay? We call this a jump. Papunta sa 60. Okay, so I have to emphasize that concentrated loads cause jump in the diagram. So yeah. So expect nyo mamaya sa 30, no? Sa point, si may jump ulit. Makita natin kung ano mangyayari. Next, so we're going from left to right, no? So tapos na tayo sa A. So doon sa mga points in between the extremes. So ito yung dalawang extreme natin, no? Extreme, extreme. Ito yung mga points sa gitna. Point B lang yung meron tayo ngayon. So at any point X between the extremes, yung shear at X, okay? Any point X is equal to yung pinanggalingan, okay? V previous plus area ng distributed loading from previous to X with the sign. Negative pag downwards yung distributed load, positive pag upwards. Sige, no? Ulitin natin to with the values. So gamitin natin yung problem natin to illustrate how you use this guide. So sabi at any pertinent point X between the extremes. So B is a pertinent point between the extremes. So we call that V sub B. And that should be equal to the previous, which is 60. Okay? Kasi dito tayo nanggaling, no? Sa A. So 60 plus yung area ng distributed loading from A to B. So ito yung distributed loading mo, no? So ano yung area niyan? It's just a rectangular load. So 15 times 6. Pero sabi, kailangan i-consider mo yung sign. So negative if downwards, positive if upwards. You can see here, a downwards loading. So kaya meron akong negative dyan. Ayun na. Solve mo na lang yan. You get negative 30. Ibig sabihin, you know that at VB, meron kang negative 30 na shear. So yung question now is, how do you connect the 60 and the negative 30? No? So meron tayong guide dito sa kaliwa on how to connect 2 points kapag ang pinanggagalingan mo is a constant slope. So you can see here that you have a constant slope, okay, loading curve. Ito yung magiging reference mo, no? Yung previous diagram. Kapag nag-draw ka ng curve ng shear, yung reference mo is the loading, okay? So you see here a constant slope, tapos yung value niya is pababa. So that's a negative value. Okay? So dito, kapag positive value and constant slope, ganito dapat yung itsura ng curve. Kapag negative value and constant slope, ganito dapat yung itsura ng curve. Okay? So sa case natin, again, this is a negative value, this is a constant slope. So if you connect 60 and 30, dapat ganito yung itsura ng curve niya. Yeah. Tapos yung degree niya should be 1. So that's one way to do it. Or yung pangalawa is just simply remember that yung next na degree is plus 1 ng pinanggalingang degree. Okay? So yung pinanggalingan natin degree is 0. So pag nag-add ka ng 1, so magiging degree na dapat nito is 1. So a 1 degree curve, ano yun? It's a straight line. So simply connect 60 and 30 with a straight line. So ganun. Madali lang kapag constant yung loading. Okay. At point B, wala tayong sudden jump ng diagram. Bakit? Wala kasing concentrated load. So, dyan lang yan. Okay, so we can now go to C, at point C, at the rightmost pertinent point. Ganun pa rin, no? Yung pinanggalingan plus area ng distributed load from the previous to the rightmost pertinent point. So, we're speaking of point C here. So, yung area is 0. Kasi wala ka namang distributed loading from B to C. That's why VC is already equal to negative 30. So, meron kang negative 30 siya. Now, pag nagko-connect ka naman ng ganyang instance, walang distributed loading doon sa loading diagram. 0 lang yung slope niyan. Yeah. In other words, a straight horizontal line. So, between B and C, there's no load. So, the curve in the shear diagram has 0 degree. Now, may kulang pa kasi nakakita kayo ng applied. So, sinasabi ko kanina na kapag may applied, ano mangyayari? May sudden jump. So, you have two values of the shear at C. So, VC is equal to negative 30 plus 30. That brings us to 0. So, from negative 30, bababa siya dapat sa 0. And that's a good sign. Bakit? Kasi kapag nag-close yung diagram, that is kapag nag-0 yung huling-huli, ibig sabihin, guide mo na yun na tama yung ginagawa mo. Yeah. As check, diagram should close at the rightmost pertinent point. Yeah. So you can see here that this is already the shear diagram. And it's completely labeled. No? So yung magnitude of the pertinent points are labeled. The degree of the curves are labeled. And you have a V here and the unit is there. So why is it important to label your diagram? Para to sa titingin ng gawa nyo, no? So mga checkers, sa mga evaluator, kung naiintindihan nyo talaga yung concept. And of course, sa exam naman kasi, lalo na kapag paper exam, yung mga straight line natin biglang lumiliko, no? So hindi masyadong clear kung anong degree. No? Yung horizontal mo pwedeng gumanon, yan, medyo kakaiba. Pero sa totoo yan, no? Kasi sa pagmamadali, pwede yan mangyari. Kaya maganda na naglalagay tayo ng mga label. Okay? Maganda kapag may label. Yon. Sige, next. Pwede na tayo mag-drawing ng moment diagram. So kapag nag-drawing tayo ng moment diagram, parehas pa rin yung reference natin is yung load and yung shear. Okay? Yon. Parehas mo siyang reference, no? Bakit? Kasi sa loading diagram, nandun yung mga applied moment natin. Sa shear diagram, dito tayo titingin no, kung ano yung magiging curvature no, ng mga beams natin sa, mga curves natin sa moment diagram. Okay, but before that, I have to note that may isa pang bullet dito. That is, another pertinent point to consider is yung intersection ng shear diagram doon sa beam. So kapag nag-intersect yung shear diagram sa beam, mag-a-add ka ng isang pertinent point, yung intersection. And we call that P. Tapos trabaho mong hanapin kung nasaan yung P. So we call this distance D, which is unknown. How do you get this distance D? Simple lang, no? You can do similar triangles. So sa video na to, yung gagamitin nating triangles are this triangle here, okay? This triangle 1. Tapos yung second triangle is a larger triangle, which is this triangle here. Yeah. I hope malinaw yan, no? So yung first triangle, yung horizontal niya is D, yung vertical niya is 60. Yung second triangle, yung horizontal niya is 6. Kasi itong length na to is 6, no? Given yun. Tapos yung vertical niya, simple lang din. We know that this is 60. Tapos, 60. We know that this is, ilan to? 30 yan. Ito yan, no? We know that this height is 30. This length is the same as this length. 30 yan. Kaya kapag nag-similar triangles kayo, so this is horizontal divided by vertical, D over 60, that's for the first triangle, is equal to 6 over 60 plus 30. And then you'll be able to solve D is equal to 4. Yeah. But there's also another way to do this, that is consider this triangle and this smaller triangle here. Makukuha mo rin dapat doon is 4 meters. So pwede yun. So we already know that D is equal to 4. And if this is 6, this is 4, then this should be 2. Pwede na tayong mag-drawing ng moment diagram. Again, we're considering every pertinent point going from left to right. So doon naman sa left's most pertinent point, isa mo lang lahat ng concentrated moments. Kaya lang meron ditong additional notes. Baliktad yung magiging convention natin, no, kapag nagdo-drawing ng moment diagram. Pag counterclockwise, typically positive yung convention kapag summation of moment, no? Pero dito, kapag nagdo-drawing ng moment diagram, kapag counterclockwise, pababa dapat siya sa diagram. Negative dapat siya. Those are two different sign conventions. Ilalagay ko dito sa taas. Kapag nagsasum kayo ng moment, positive yung counterclockwise. Kapag nagdo-draw ng moment diagram, negative yung counterclockwise. Okay? There's an explanation for that. That is, yung sa summation of moment, external forces yung sinasum mo. Doon sa moment diagram, internal yung dinodrawing mo. Yun yung short explanation. So you can ask me in the comments if you want me to expound this, but otherwise, yun yung short explanation. Okay? That's why yung M natin, bababa siya dapat by 45. Now, so that's one pertinent point. Next na pertinent point is P. Yun, so going from left to right, no? So just like the shear diagram, gagawin mo lang is kukunin mo yung pinanggalingan, tapos i-add mo yung area. Anong area naman? Area ng shear diagram with the sign. Paano malalaman yung sign? Kapag yung diagram is nasa taas, positive yan. Okay, pag nasa baba, negative. Yan. So, for negative 45, ang kailangan mong area is yung area ng triangle from A to P. A to Papa. So, that's 1/2, 60 times 4. Tapos, again, it should be positive kasi pataas. Nasa taas ng beam yung, yung curve. So, from there, makukuha mo is 75. So, ibig sabihin, from negative 45, aangat siya to 75. Ito na naman yung problem natin. Paano magko-connect ng 2 points from 45 to 75? So, madali lang, no? Magkakaroon tayo ng guide dito. So, una-una, sinabi ko kanina na yung magiging degree nito is +1 ng degree nung nauna, no? So, yung degree ng M should be 1, okay, +1. So, that's a 2-degree curve. Kaya lang, anong curvature? Yun yung magiging problema natin. And meron lang tayong simple guide dito, no? Dito sa baba. Okay, now, kapag positive yung value, kapag yung plot ng shear ay nasa taas, tapos magnitude niya is decreasing, ganito dapat yung itsura ng curve. Kapag positive yung value, yung plot is nasa taas, tapos increasing in magnitude naman, ganito dapat yung curve. Kapag negative naman yung value, yung plot is nasa baba, tapos decreasing in magnitude, ganito dapat. And lastly, kapag negative value, increasing yung magnitude, ganito dapat. Okay, now i-apply natin tong guide na to sa ating case, no? So, ano ba to? Yung shear natin, nasa taas siya ng beam. Okay? Again, nagdodraw tayo ng moment diagram, so yung reference natin should be the shear. So, nasa taas ng beam yung 60, no? So, that's a positive value. So it's either this one or this one. Now, ano ibig sabihin ng pangalawang line about the magnitude? Titingnan mo kung ano nangyayari doon sa magnitude ng shear, no? So from 60, naging ano siya? Naging 0. Nag-cross siya ng diagram, no? 60 to 0. Ano nangyari? Nabawasan. In other words, nag-decrease siya in magnitude. So therefore, we know that the correct curve should look like this. So ito yun. And that's a 2-degree curve. Okay, hope that's clear. Again, no? Positive. Titignan mo muna yung value kung nasa taas siya or nasa baba ng diagram. Tapos titignan mo siya kung paano siya nagdi-decrease or na nag-i-increase in magnitude, no? Magnitude pinag-usapan, absolute value. Okay. Now, pwede tayong magpunta doon sa next pertinent point, which is point B. So this is still a point in between the extremes. So ito pa rin yung gagamitin natin guide. So yung pinanggalingan natin is 75. Okay? Tapos yung next na area is itong area ng triangle na to, which is 1/2 30 times 2. And this is a negative area kasi nandun siya sa baba. You will notice na yung negative ng force nilalabas ko, no? So don't commit the double negative mistake na nag-negative ka dito tapos magne-negative ka pa ulit dito. So that's a double negative, no? Huwag yun. So pag sinuot mo yan, you'll get a 45. So may 45 ka dito. So yung next mong problema is paano na i-connect. O gagamitin natin yung guide na to. So using this guide, no, i-observe muna natin yung value ng shear diagram. So this triangle here, okay, is below the beam. So that's a negative value. So it's either this one in this quadrant or itong quadrant na ito na nasa baba. As you observe the magnitude of the shear as you go from left to right. From 0, naging negative 30 siya, no? So, yung absolute value niya nag-i-increase. So, this is a negative value and increasing in magnitude. So, ganito dapat yung shape niya. Tapos, label your curve, 2 degree. So, this is a 2-degree curve. This is a 2-degree curve. Okay. Well, that's clear. Next, at the rightmost pertinent point, so we're done with B na. So, doon na tayo sa pinakadulo, no? Sa C. So, ang gagawin mo lang is yung pinanggalingan again. So, at the rightmost pertinent point, M previous, which is yung pinanggalingan plus area ng shear diagram from previous to the rightmost pertinent point. So, you get 45, yun yung pinanggalingan, plus the area of this small rectangle here, which is 30 times 1.5. And don't forget, this is a negative area kasi nasa baba siya ng diagram. And you'll notice that kapag sinod mo to, magzi-zero na siya. Yun na, nag-close na yung diagram natin. But, you have to connect, no, these 2 points. So this is a 0-degree curve. This is a constant slope, no? So ito yung case na gagamitin. Ito yung guide na gagamitin natin. So constant slope, tapos titignan mo, positive or negative value? Negative kasi nasa baba siya ng beam, so ganito dapat yung itsura niya. Okay? Yan. And this is 1 degree. Or you simply connect it linearly, no? Kasi alam mo naman na 0 plus 1, 1-degree curve siya. So yun, I think that's the moment diagram. But just a note na aside from the 45 kilonewton meter load, wala nang nangyaring jump. No? Ito lang yung jump na meron tayo. As checked, again, diagram should close at the rightmost pertinent point. So we're done with letter A. Next, determine the magnitude and the location of the maximum absolute value of the bending moment. So ito yung magiging reference natin. It's easy to see that the maximum absolute value of the bending moment is 75, and it occurs at the right of support A, 4 meters to the right of support A. So that's your answer to B. So that ends our video, and I hope you learned something new today and hope you can use this as a review. So the reference of this video is Vector Mechanics for Engineer Statics and Dynamics from by Beer et al. 2016 version in this section 7.3.